All right. So today we're doing the rest of the congruence postulates for how to tell congruent triangles. So what were the two that we learned yesterday? SSS and SAS. What do those two acronyms stand for? Right. Side, 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 angle, side. Meaning, if we had two triangles, we can tell they're congruent if all three sides are congruent, or we can tell they're congruent if two of the corresponding sides are congruent and the angle formed between those two congruent sides are congruent. So remember, the angle has to be made up of those two congruent sides. All right. If, let's say, you're only given this angle here, it's now no longer side, side, side. If you think about it in order, it spells ASS. We don't want any dirty words in my class, okay? Just saying. So, that's not a postulate, by the way. There's no side, side, angle. And there's no ASS either. Angle, side, side. So, that's a way you can remember that that's not a postulate. All right? Just saying. Now, the last three that we're going to learn today deal more with the angles. All right? So, we're dealing with angle, side, angle, angle, side, and HL, which stands for hypotenuse leg. All right? So, let's just go through these very quickly. And I forgot my pen at my desk. All right. So angle, side, angle is exactly what you think it means. Very similar to side, angle, side, except instead of having the angle made up of the two sides, the side in question is between two angles. All right. So if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the triangles are congruent. All right. So remember, we talked about what included angle means. Included side is pretty much the same as an included angle. It just means the side between two angles. That's all included side means. It's similar to included angle. So let's look at an example here. So they're saying that triangle GHJ is congruent to triangle FEG. Now, if you look, they marked two angles that are congruent. And then if you look at the side between those two angles, it's also congruent. So another way you can think about it is that the congruent side should be made up, should be part of each angle. All right. So if you're trying to figure out, okay, how do I know if it's angle, side, angle? Obviously, the side's between the two, but it's also a ray that makes up both angles. All right. If you notice, this one has a congruent side, and this angle has a congruent side as far as its rays. All right. So again, we would say it's congruent by angle, side, angle, because we have a congruent side between two congruent angles. Now, same thing here. We can also say these are congruent by ASA, so angle, side, angle. Now, we talked about this yesterday. Why can we say this is angle, side, angle, even though the congruent side is not marked? Right, they share a side. Does anyone remember what property that's called? It's a reflexive property. So, because they share a side, we can assume that it's congruent to itself by the reflexive property. So again, it's angle side angle, specifically by the reflexive property. All right. Any question on angle side angle? Now, the next postulate is angle angle side. All right. So if two angles in a non-included side of one triangle are congruent, to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. All right. So again, non-included side, it means it's not between the two angles. All right. It would only make up the ray of one of the angles. So, like I said yesterday, when it comes to these postulates, order does matter. So, you have to look to see, like, if you did a big circle around the triangle, you just pick a spot where to start. What do you have? Like, what part's congruent? So, for example, with this one, let's say I started at N and I went clockwise. All right, that's actually counterclockwise. So I started at N. That's an angle that's congruent. Another angle, and then a side. All right. So another way you can do is if you start at the side, you want side, angle, angle. It's the same thing as angle, angle, side. All right. Now, you may be asking, but what if I go this way? It's angle, side, angle. It's not because, right, we have a side right here, and this side is not between the two angles. If it was here, it would be angle, side, angle. All right. So be very careful with the order. More often than not, I see people confuse angle, angle, side, and angle, side, angle because they are very, very similar. All right. So again, this is angle, angle, side because the congruent side is not between the two angles. And the last example, again, it's angle, angle, side because of the reflexive property. Again, it shares that side, so we can say it's angle, angle, side. So it's angle, angle, side by the reflexive property. Because if they share a side, we can assume that it is congruent to itself. Any questions on angle, angle, side? So again, excuse me. So again, the way you tell the difference between angle, side, angle, and angle, angle, side is that side, if it's between the two angles, it's angle, side, angle. If it's not between the two angles, it's angle, angle, side. All right. Now, recall the third angle theorem. So this is why if we have two angles that are congruent, we can essentially say that the other angle of the triangle is congruent. Now, at the very least, based off of this theorem, if two angles are congruent, we have a similar triangle, meaning same shape, different sides. By throwing in that congruent side, that's how we know that they're congruent. All right. So if two angles of one triangle are congruent to two angles of the second triangle, then the third angle of the triangles are congruent. All right, and again, that's because of the triangle sum theorem. So we know this to be true because of the triangle sum theorem. All right, we have two congruent angles, add them together, subtract from 180, it'll give you the same angle as the third angle. So just to kind of recap it, it's saying that if angle C and angle K are congruent, angle B and angle J are congruent, then angle A must be congruent to angle L. So these two angles must be congruent because we have two other sets of congruent angles. So, again, the third angle theorem explains why AAS and ASA work, at least in terms of similarity. It's the inclusion of that one congruent side that tells us, okay, if one of the sides are congruent, and we know two of the angles are congruent, so that means the third angle is congruent, we have to assume that the other two sides are congruent. All right, because remember, one side can dictate how long the rest of the triangle is if we already know what the angles are. All right, does that make sense? All right, so let's do some examples here. Okay, yeah. All right, so we're going to do a couple of these. So we're going to state whether or not they're congruent and how we know. So whether or not they're congruent and what postulate tells us. So for number one, what do you think? So first off, is it congruent or not? What do you guys think? Yeah, it's congruent. Someone raise your hand and tell me by what postulate. Not side, angle, side. Say it again. Angle, side, angle. All right, so we have two sets of congruent angles, and then since they share a side between those two angles, we can say they're congruent by angle, side, angle. All right. What about number three? First off, do you think they're congruent? Yes, they are congruent. How do I know? Angle, angle, side. How did you tell it was angle, angle, side if only one angle is marked? Right, so these two angles are what to each other? Vertical, and vertical angles are congruent. So we could mark these as congruent angles, meaning we have an angle, angle, side. So they're congruent by angle, angle, side. What about number four? Can we assume congruency given what's given for number four? I see kind of a mix. There's some nods, there's some shakes of the head. So these are, we cannot assume congruency here. Can anyone tell me why? Right, there's no congruent angles marked. All right, so there's no way we can make it ASA or AAS or SAS. And that third side isn't marked either, so we can't assume it's side, side, side. All right, so because we do not have enough information, we can only assume it's not congruent, and it's mainly because not enough info. And like I said yesterday, that you will come across cases like that. Remember, innocent until proven guilty. Not congruent until proven congruent. All right? That's how you should always approach these. Assume that they're not congruent until you have enough information to say they are. All right, let's do one more. Number 7. What do you think? Are they congruent or not? So what do you guys think? Yes or no? Oh, not congruent. Why? There's no congruent sides marked. The only thing that's marked are the angles. And what did I say yesterday about congruent angles? So if we only know the angles are congruent, we cannot assume that the triangles are congruent. Why? Right, because dilations exist. All right. So when we did transformations in our last unit, remember dilations create the same shape, meaning they have the same angles, but they can be different sizes. All right. Even though these look like they're the same size, we cannot assume they're the same size because for all we know, they're not drawn to scale. All right. So even though we have 3 congruent angles, we cannot assume it's congruent because there's no congruent sides marked. At the very least, we can say the triangles are similar. All right, so when we talk about similarity in our next unit, at the very least, we can assume that these 2 triangles are similar to each other, meaning they're the same shape, but we cannot prove that they're the same size. Any questions on that? All right. So, for number 1 here, given the additional piece of information, all right, so given these 2 triangles, we're trying to prove it by ASA. So, angle, side angle. What do I need in order to prove it's congruent by angle, side angle? What else needs to be marked? So we need A to D, and we also need what? C to D. So I need to show that AD and CD are congruent. All right. Because remember, if we mark the reflexive property side, all right, that would give us angle, side, side. What's that acronym? Don't say the word. Side, side. Or side, side angle. Think about it. Side, side angle spelled backwards is? Oh, never mind. Yeah. All right. So, we don't want any bad words in this class. All right. All right. Now, what piece of information do I need to make angle, angle, side here? Now, for this one, there's 2 answers that can work. Any guesses? Well, we need to know that K is congruent, which we can assume that because it's... So we either need to know that K is congruent to K, or we could also figure out if J is congruent to M. Either way would give us an angle, angle, side. All right, so if you picked either of those angles to make them congruent, that's how we would know. All right. Now, K is pretty straightforward because they're vertical. That would be an easy proof. All right. J and M, we probably would need more information. All right. So, here is the postulates that do not work. All right. The first one is angle, angle, angle. That's the first postulate that does not work. Because remember what I just said about that. Even though we know all three angles are congruent, without a congruent side, we have no clue if they are the same size or not, right? Because dilations do exist. The second one that does not work is angle, side, side, or I'm going to spell it as side, side, angle because I do not want to write a specific word on my paper. All right? So, the reason this one doesn't work is even though we know one angle is congruent and two of the sides are congruent, without knowing that at least another angle or that this side is congruent, there's no way we can say it's a congruent triangle. Because if we think about it, even though these two sides can be congruent, these two angles can be completely different. All right? Even though this angle is congruent and it has this congruent side, without knowing if this side is congruent, we have that angle could, be smaller or larger or whatever. All right? So that's the other one that does not work. And the way you can remember that one is you don't want a bad word written on your paper. All right? So if you don't know what that word is, spell that backwards. All right? So those are the two main ones that you may see, like given to you, like if I ask if it's congruent or not, and you would say no, they're not congruent. Mainly because one is because of that postulate, which is not even a postulate, but two, we just don't have enough information. All right. Now, there is, however, one special case of a lovely bad word that does work, but it only works with a right triangle. All right. So the only way that this works is with a right triangle. And we call this hypotenuse leg. And what that looks like is that if I have two right triangles, if the hypotenuse of the two triangles are congruent and at least one of the legs is congruent, then the triangles are congruent. And the reason for that is because we know that a right triangle will always have a 90-degree angle. All right, so that would be the congruent angle here. All right. If one of the sides are congruent and the hypotenuse is congruent, the big thing is the hypotenuse has to be congruent because the hypotenuse dictates how long the other two sides are for that 90-degree angle. All right, that's the only version of SSA that works. All right, and it only works for right triangles. All right, does that make sense? So this hypotenuse leg, or HL as it's known as, is the last postulate. All right, but it's a very special case of postulate. All right, do you guys need to see me do any more examples with saying if they're congruent or not, or do you guys think you're fairly good? Speak now, forever hold your peace. You need another example? Okay. All right. So let's do some examples on this page. So let's look at number 1. Are those two congruent? Yes or no? Yes. By what postulate? Side, side, side. Good. We have 3 sides that are marked, so we can say they're congruent by side, side, side. What about number 6? Congruent or no? No. Why? It's angle, angle, angle. So no, or not congruent because it's angle, angle, angle. What about 11? Congruent or no? Yes. Why? They share a side. So this is congruent, which makes it what postulate? Side, angle, side. All right. Yes. So number 2. So number 2, what do you guys think? Congruent or not congruent? They are technically congruent, but is this going to be by HL or side, angle, side? Side, angle, side. So even though it is a right triangle, it's still congruent because the 2 legs are congruent. All right. The hypotenuse is not marked, so it's automatically not hypotenuse leg. All right. So the only time you can say it's hypotenuse leg is if the hypotenuse is one of those congruent sides. All right. So this one is congruent by side, angle, side. What about 3? Yes or no? No, it's not. Why? The angle's not between the 2 sides, so it spells what? SSA. All right. So it's side, side, angle, or, and I'm not going to say it. So it's not congruent because of SSA. All right. Is everyone understanding these? Am I going too quickly, or is it? All right. Let's do one more. So look at part 2, number 2. What do you think? So yes, they're congruent, but by what postulate? It's technically SSA, but it's a special case. What's the special case called? Hypotenuse leg. So they share this leg, so we can assume it's congruent. The hypotenuse, or the side directly across from the right angle, is congruent. And of course, we have the right angle. So even though it is SSA, we call it hypotenuse leg. Okay, I know I said that was the last one, but one more. 8. What do you think? It is hypotenuse leg. Now, why can I assume that these 2 sides are congruent specifically? So they have the same marks, but what about this part right here? That's the part that's not marked. Don't they share it? Right, so we can assume that from here to here is also congruent. So those 2 sides are congruent. All right, so that's another hypotenuse leg. Any questions on identifying congruent triangles based off of the postulates? All right, so you guys have the rest of the class time for doing homework, all right? you have like a solid almost 50 minutes. All right. So, there is a new Delta math. It'll be due, I think I said it for Monday by midnight or Tuesday. I don't remember off the top of my head. All right. The due date's already in there though. All right. There's no one for today. All right. It does cover 2.4. So use this time and work through those. All right. So there's Delta maths. I'm not going to assign any paper homework for tonight. All right. So I'm not going to assign any paper homework for tonight, but it'll be a good time to work on your Delta maths. Remember, 2 of them are due tonight by midnight, so make sure you get those 2 done. I believe it's the 2.1 and the 2.2 first part.